Hi guys, today we'll be doing AS Chemistry 9701 Redox reactions. So let's get started. For redox reactions come from two words combined together. The red in reactions stand for reduction, and the ox in redox reaction stands for oxidation. Now moving on to the definitions. Reduction is a process of gain of electrons, the gain of hydrogen, the loss of hydrogen, and the decrease in oxidation number. Similarly, oxidation is the complete opposite of reduction. It's the loss of electrons, the loss of hydrogen, and the gain of oxygen, and increase in oxidation number. So, the easier way to remember this is, for example, the gain of oxygen and the loss of oxygen. These two are the easiest to remember, as well as this one, increase in oxidation number and decrease in oxidation number. For example, there's an element for, I'll tell it for oxidation. There's an element Cl2. Now its oxidation number is 0, right? We'll be doing this afterwards as well. And it converts and it is converted into chloride, which has a minus charge on it. So if it's going from 0 to -1, that's the decrease in oxidation number, so that is reduction. So as I was telling, redox reactions are made up of both reduction they're made up of both reduction and oxidation. So for example, it is made up of two half reactions. One half reaction is of oxidation and one half reaction is of reduction, making it an overall redox reaction. I've written it as well. Redox reactions are made up of both oxidation and reduction. Doesn't matter what the order is, but one half reaction will be of oxidation, one half reaction will be of reduction. Okay, and then the two half equations will make over an overall redox reaction. Now moving on to the examples. For example, I have here chloride and I have here chlorine, which is getting converted into chloride. Okay, as we can see. Now you have to identify whether it is reduction or oxidation. As we can see, there is a gain of electron here, and also we can see with regards to oxidation number here. With regards to oxidation number, we can see, as I told you an example here, it is going from 0 to -1, which means it is reduction, right? So this is reduction. And then we have iodide getting converted into iodine, and here we can see there is loss of electrons, so that means it is oxidation. Also, I minus, the oxidation number is -1, and in here it is 0, so we can see from -1 to 0 it is an increase in oxidation number, right? I'll be doing the definition of oxidation number after these examples. So this one we identified as oxidation, right? And the overall, as I said, the overall two half equations, these are the two half equations. They'll overall make, we'll add them together and they'll overall make the overall reaction. So what happens in making the overall reaction is that the one in reactant side, both Cl2 and plus 2, will also have to make sure that both on both sides the electrons are equal, like they're balanced, so that they can be cut in the overall reaction. In the overall reaction, electrons are not included. I can write it here as well. In the overall reaction, electrons are not included. So that means on both side reactants and products, electrons should be balanced in order uh, for them to get cancelled out. Okay, so the overall redox reaction for this equation will turn out to be this. We can see we have Cl2 here. Oh my god, wait. Okay, so we have Cl2 here. Since we have two electrons on the reactant side, two electrons on the product side, that means that they'll be getting cancelled. Okay, they'll be getting cancelled. Then we'll have Cl2 and 2I minus on the reactant side. Then we'll have um, iodine and chloride on the product side. And we can also see that, again we can see that it's going from 0 to -1, and this one is going from -1 to 0. One reaction is oxidation and the other is reduction. Moving on, I have a different example for you. Reaction between Mg and O2. Okay, so I have a reaction between Mg and O2. So in AS, what happens is you are giving a data booklet, but I think nowadays you are not given a data booklet, but you will be given the reactions that you need. So what the matter is, you don't need to concern yourself with these values. These are for A2. Okay. Now here in the data booklet, everything is given in an alphabetical order, as you can see, and also everything is given in reduction form. For example, you can see all these electrons, they're getting gained, they're being added. So everything is given in reduction form, right? So, but we know that not only reduction doesn't happen, both oxidation and reduction happen. So, for example, in this equation, we have reaction between Mg and O2. Now we'll search for the Mg magnesium's reaction. Here it is. Mg plus 2 electrons turning Mg2 plus 2 electrons turning into magnesium. Okay, now I have written it down here as well, copied it as it is from the data booklet. Okay, so this was the reaction that we just read, but we know that in this equation, as I said, that magnesium and oxygen is reacting. So magnesium and oxygen will be on the reactant side, right? Not on the and here magnesium is converting. That's the product. So what we have to do? Okay, they are both the reactants. So what we'll have to do is flip the equation, right? And the flipping the equation just means like doing what it says, like flipping the entire equation. Mg comes on the reactant side, Mg2 plus comes on the Mg2 plus and 2 electrons comes on the product side. And then this means this is not reduction anymore, this is oxidation, right? Mg is 0 here, it's getting converted to 0 to 2 plus. There's an increase in oxidation number, and that's oxidation. For O2, we have this equation in the data booklet too, and that's the equation. Also, as I said, we'll have to make sure that let me erase this thing. Wait. Okay, as I said, we have to make sure that both electrons on both sides is balanced. But here it is not balanced. On the product sides there are 2 electrons, and on the reactant side there are 4 electrons. So what we'll have to do is just multiply this entire equation by 2, and we are not just multiplying the electrons, we are multiplying the entire equation. You have to remember that. And thus the overall equation comes out to be 2 mg, because we have multiplied mg by 2, 2 mg plus O2, and electrons on both sides will be cancelled, and then we have the entire overall equation. Moving on, I hope you guys understood this. If you have any problem, you can ask me. Okay, moving on, we'll be doing the definition of oxidation number. It is what it is. Like we just saw that. Let me. So oxidation number is charge on an ion, on an ion, right? As we say, as we saw. Okay, wait. As you saw, Mg is so the charge on this thing. This thing is the oxidation number. This thing is the oxidation number. So that's what it is. You have to remember two most important things about oxidation number is that in element form, oxidation number is 0. Okay. And what do I mean by in element form is, for example, you have Cl2, you have Na plus, you have, these are all in their elemental form and their oxidation number will be 0. Okay. Also, stable compounds have an overall charge of 0. They don't have like not the elements, but the whole compound will have an overall charge of 0. For example, you have H2SO4. The overall charge on this compound will be 0, not on like separate elements like H2, or what I'm saying is not on separate elements like in H2SO4, for example. The overall charge is 0, like this whole compound is 0, but H2 has its own charge, S has its own charge which is not equal to 0. Also O also has its own charge which is not equal to 0, right? The overall compound is 0. Now we'll be doing some exercise on this thing, oxidation number, finding out oxidation number. It's one of the most asked questions. You can expect a question from this oxidation number thing. So find the oxidation number of underlined species. Let me I'll be doing it with you guys, but you guys can also pause the video and attempt it yourself. That will be very good. So here, let me underline the species. It's usually safe for now. Okay, I have underlined the species. Let us start with H2SO4. It is the most easiest example. We start with the most easiest one. Okay, so we know there are 2 hydrogen in this thing. We write 2, right? The oxidation number of hydrogen is +1. You all know. Now we have to find the oxidation number of silver, which is X, plus we have 4 oxygen, and each oxygen has an oxidation number of -2. The overall charge on the compound is 0. Now this is 2 plus X and -8 is equals to 0. 2 minus 8 is -6. X is equals to +6, right? Moving on with this, We know the oxidation number of hydrogen is +1. We don't know the oxidation number of sulfur. We know there are four oxygen here, and on each there is an oxidation number of -2. The overall charge on the compound is not 0 here, as we can see it is -1, right? You have to be very very careful with this thing. So +1 plus x minus 8 is equals to -1. -7 plus x is equals to -1. X is equals to this will convert it into +7, right? And we'll have the oxidation number of +6 on sulfur. Now on SO2 plus SO2, this is just SO2. So we don't know the oxidation number of sulfur. Plus we know there are two oxygen here, and on each it's a -2 charge, and the overall compound here is 0. X minus 4 is equals to 0. X will be +4. Now with hydrogen sulfide, we know it has a +1 charge. We don't know the charge on sulfur. The overall compound is 0. 2 plus x is equals to 0. X will be -2. Right? Now this one is more important. If you guys did this, I know that you guys were listening to me. What do you guys say? Let's do this one first. The last one, you guys can take some time to do that one. Let's do this one first, okay? So the charge oxidation number of Na plus is +1. We don't know the oxidation number of fluorine. Usually it is -1, but since, wait, let me tell you. Please wait a minute, my pen stopped operating. Okay, so as I was saying, usually it is -1, but since it is an underlying species in this case, we'll say it is x. We don't know, we have to find it out. You cannot just say it is -1, okay? You will have to find it out. So it is x in this case, and there are 3 oxygen here, E, and on each it is -2. The overall compound charge is 0. We cannot see any charge here, that means it is 0. It is as simple as it is, okay? So it is +1 plus x and -6 is equals to 0. -5 plus x is equals to 0. In this case, the oxidation number of fluorine is +5. Right, moving on this N2. As I said here on this one, you can see here. Here, as I said, in element form, oxidation number is 0. And N2 is also an example here, if you guys were careful enough to read this. So the oxidation number of this charge will be 0. It is in element form. Don't waste your time in thinking what will be the oxidation number here, what will be, how am I supposed to find it? You just have to not find it. Oh my god, wait. Okay. Now moving on, we'll see how questions usually come in the exam. How can you expect? First of all, you can be given two half equations, and then you will have to make an overall redox reaction with those. That means you don't have to use a data booklet to find the half equations. They'll be given to you, okay? Overall redox reaction you will have to find with this. For example, these are the two equations that will be given to you, for example. So okay, wait. Okay, so these are the two equations given to you. Fe2 plus is getting converted to Fe3 plus. MnO4 minus is Fe2 plus is getting converted to Fe3 plus. MnO4 minus is getting converted to Mn2 plus. Okay, the two things you'll have to first of all do is identify which is getting oxidized and which is getting reduced. You'll have to know. Sometimes they give you the exact equations from the data booklet, As you can see, all these equations are getting reduced, so then you'll have to flip these equations. But right now, on one side, um, as we can see, it is losing electrons. Losing electrons means it is on the product side. Losing electrons are on the product side, right? That is as simple. And then we can also see Fe2 plus is 2 plus and it is getting converted to 3 plus. That means it is losing electrons. We now have two evidences of our overall conclusion, that it is converting from 2 plus to 3 plus and it is losing electrons. That means the half equation is of oxidation, right? It is of oxidation, right? Okay, and then we can see here it is MnO4 minus. So we'll have to find the oxidation. Do not assume that it's converting it to it is getting converted from -1 to +2. Okay, this is not what it is. There is Mn here, that is on manganese. The charge is only on manganese and not. And this is the overall compound equation, or the charge is on the overall compound, right? So let me clear this thing and then we. So what you'll have to do is, there is Mn here and there is Mn2 plus. What we'll have to do is here MnO4 minus. We have to find the charge oxidation number of this manganese, which is X plus 4 into -2, that is the charge on oxygen, and then -1. X minus 8 is equals to -1. X is equals to -1 plus 7. X is equals to plus 6, right? So the charge on a manganese is plus 6, right? It is not -1. For example, if we assume that it was going from -1 to +2, that is an increase in oxidation number. So we'll have oxidation here, but we don't have oxidation here. This is not an oxidation reaction, right? So this is a reduction reaction. Plus, the actual manganese is going from +6 to +2. That is -4 decrease in oxidation number. So this is reduction, right? I'll just have to clear this thing so that I have some space for me. Also, I'm clearing this thing. It looks not good. Okay. So here we identified it as reduction. Also, the second evidence is that we have electrons on the reactant side. That means it is a reduction. Also, as I said, you'll have to. Okay, as I was saying, as I said earlier, the electrons on both sides should be balanced. We have one electron here on the product side, and we have 5 electrons here on the reactant side. So we'll have to multiply the overall equation by 5. I'm doing this here because I do have a space, but still. So our overall equation will come out to be F5 Fe2 plus MnO4. We'll write H plus and H2 as it is, because we're not multiplying that equation, we are multiplying the above equation. So that's why we are having 5 here. The electrons will get cancelled out and the overall equation will become this. Secondly, how they ask the question is, the overall equation is given and then you'll have to balance that. Okay, the overall equation is, for example, you are given this and now you're asked to balance this. What you'll have to do is go to the data booklet, see what reaction you'll have to pick out. Now you guys have it easy. You don't have the entire equation, but you'll be given a they'll give you a table or something, and it will have some equations, and it will be easier to pick it out, like from rather than from the whole, I don't know how many equations. It is easier to pick it out from 2 to 3 equations. We know, as we can see, we can see from the data booklet. Wait, where is the equation? Okay, here. Fe3 plus electrons, this is a reduction, it is converted into Fe2 plus. Here we have Fe2 plus here. Let me, so this is the equation from the data booklet. Okay, Fe3 plus getting converted into Fe2 plus. But here on the reactant side we can see Fe2 plus is on the reactant side, not Fe3 plus. So what we'll have to do is just flip the equation, right? Okay, we have flipped the equation. We have Fe2 plus on the reactant side now. We have Fe3 plus on the product side. And this is an overall oxidation reaction. Because if we take both reaction, then we'll both have the reduction reaction. But that cannot be the case. One has to be oxidation and one has to be reduction, right? Now, secondly, the second equation will be from the data booklet as well. Okay, this is the second equation. What happened to my M? Okay, this is the second equation. MnO4 is getting converted to Mn2 plus. We saw this here as well. It is going from +6 to +2. That is reduction, right? Reduction. And then to balance out the electrons, we have multiplied this thing by 5. And adding these two equations, we'll get the overall equation. You will have to do some work. This requires you to do work even in order to balance this, and this will be of like 1 mark, 2 mark. That's how this works. So looking at this overall equation, we can fill these gaps. We have 5 Fe2 plus, we have 1 MnO4 minus, we have 8H plus, happened 1 minute. We have 8H plus, we have 5 Fe3 plus, and we have 4H2O, right? And that's how you do this equation, do this question. Okay, third point, they'll give you an overall equation and they'll ask you the half equations from that. Now the overall equation, for example, will be this, and they're asking you to make 2 half equations from this, one oxidation and one reduction. Now we'll use the data booklet. We have Zn on the reactant side, we have Zn2 plus. We'll see what we have in the data booklet, right? So this is, here it is, Zn2 plus 2 electrons converting into zinc, right? And that's what I have copied here. This is what we just read from the data booklet, right? Okay, so as we can see, there zinc 2 plus. Okay, so as I was saying, we have zinc on the reactant side here, but in this equation we have zinc 2 plus on the reactant side. So what we'll have to do is flip the equation. Okay, wait, we'll have to flip the equation, right? And we have flipped it. We have zinc on the reactant side and zinc 2 plus on the product side. Now we are safe. So this is an oxidation reaction. Electrons are on the product side. Zinc is going from 0 to 2 plus. It is an oxidation reaction. So now what we'll have to do is just minus the entire thing. Wait, minus this equation with this equation, and we'll have the next half equation with us. So as we can see, there are 5 zinc on this reactant side, but we have only one thing here, so we'll multiply the equation by 5 and I think that is because we have to balance the electrons. We can see it in the next half equation now. So we'll have, for the next half equation, we'll have 2IO3 minus, right? We'll have 12H plus. What is happening to my... okay. We'll have 12H plus. We'll have 10 electrons in order to balance out the entire equation, right? We'll have iodine here. That's not iodine here. And then we have 6H2. You can cross check this equation with this equation, and you'll see that we have it correct. Okay, now moving on. Let's not highlight it that much. Okay, wait. Okay, moving on. You can, the last type of question you can be given. You can be given this. For example, you're given half equation, but these are not like exactly half equation. We don't have the electrons yet. Okay, then you are instructed to construct an overall equation. What you'll have to do is go to the data booklet or the table that you have been given, and you will have to find out the half equations. So this is the, let's do an overall one. Okay, so these are the equations that are given in the data booklet. You can also see it from here as well. This one, I have highlighted everything. Okay, so this is the equation, Ag plus getting converted into Ag, and we have this one. We have already used this one. Fe3 plus getting converted to Fe2 plus. Okay, I have written down it is exactly from the data booklet. Now we can see this one. We know it is from Fe3 plus to Fe2 plus. That means this is on the reactant side. Okay, and this silver will be on the reactant side, not Ag plus. Okay, but in this equation we can see that Ag plus is on the reactant side, so we'll have to flip the equation. Also, if we don't flip the equation, for example, you can see that that this equation is reduction, right? Plus 3 to plus 2, what it is? Reduction. And if we consider this equation, it is going from plus 1 to 0, and that is also reduction. But that cannot be the case. We'll have one oxidation and one reduction. You'll have to be very careful with this thing. And then we'll just have to add both the equations, and we get an overall redox reaction. We have to add both the equation, I mean by this equation and this equation, not this one. Okay. Okay, now there is the last thing we'll have to do, which is constructing half equation. If you're not given any half equation, they say that you have to construct it yourself. For example, you have been given two species, you don't know what to do with these, you'll have to construct the half equation with this. Now you cannot just add electrons and just be done with it. You have to take it step by step. Let's start. The first thing we'll have to do is calculate the oxidation number of both these species. And please open your eyes and see that these two species are different. Okay, the 2 and the plus is different, is placed differently. So we have the two species with us, and we'll find the oxidation number of these. Oxidation number of vanadium. Okay, that is the main thing, not oxygen. Okay, so X is for vanadium plus minus 2, and the overall charge on the compound is plus 2. Okay, that is not the charge on itself. Okay, X, wait, X minus 2 plus 2, X is equal to plus 4. Okay, here we have X plus we have two oxygen here, and not the overall charge is not 2 plus, it is only plus 1. Hmm, why am I running so fast? Okay, overall charge on the compound is plus 1, x is minus 4, and then we have plus 1 here. So now we can see the oxidation number is increasing, right? It is going from plus 4 to plus 5. That means that our half equation will be of oxidation. Okay. Next step will be balance the element changing the oxidation number. Now we just calculated the change in oxidation number is of vanadium, and we already have, like for example, we have one vanadium on the reactant side. We can see one vanadium on the product side. So that means it is already balanced in this one. Okay. That may not be the case in every equation that you get. Okay. Now we'll have to sort out the electrons. And how do we do that? We do that by, we know that a vanadium is going from plus 4 to plus 5. That means there is a change in one electron, and it is oxidation. That means it is a loss of electrons, right? So in loss of electrons, we have electrons on the product side, and there is change of one electron, and it is oxidation. So we'll have one electron on the product side, right? Moving on, now we'll have to sort out the oxygens. As we can see here, we have one oxygen here, but we have two oxygen here. So we'll have to sort that out as well. Our equations in chemistry should always be balanced. They look the best when they are balanced, and you get the marks as well. So for sorting out the oxygen, you will have to use H2O. Now I know this is adding a hydrogen as well, and that's another problem, but let's take it a step by step. Sorting out the oxygen, for like each oxygen, you'll have to use one H2O. For example, you have one oxygen here. Okay, wait, what happened here? Okay. Okay, so you have one oxygen here and you have two oxygen here. So we need one more oxygen here, right? Okay, so what I was saying, we need to add like one oxygen here. So what we'll do is add one hydrogen on the reactant side, right? For one oxygen, we use one water molecule. So that's how you do it. Now we have one oxygen here, we have one oxygen here, two oxygen and two oxygen on the product side. Moving on, now we can see we have two hydrogen here and we have no hydrogen on the product side. So we'll have to balance that out as well. Okay, so for sorting out the hydrogen, we use H plus, and that is very simple. You guys don't have to worry it's too uh, difficult or anything. So what we'll have to do is, we have two hydrogen we have two hydrogen here, so we'll add two hydrogen on the product side, right? And then the last step will be checked by ensuring that the charges on each side are balanced. Now we have done so much in this thing, the charges should be balanced, by the way. Okay, so we do it. So that's how it is, that we can see that we have BO2 plus. H2 is a stable compound, and stable compound oxidation number is 0. Then we have BO2 plus. This charge is plus. here. The charge on an electron is -1, and we have, I don't know what happened with this thing. Okay. And we have 2H plus here. Do not take it as H plus only 1 plus. We have 2 hydrogen here. So we'll have to take 2 plus charge. This plus 1, this -1 gets cancelled out. We have both +2 on the reactant side and +2 on the product side. And that's all about it for redox reactions. You guys don't have to do anything else for AS chemistry redox reactions. These are all the notes that you need. I hope you guys understood what I was trying to teach you. I hope you guys uh, have no difficulty in doing past paper questions. I'll be putting the whole document in the description of my video. You can check it out as well. Okay, thank you so much. Goodbye.